sticks. And the number isn't valid.
All right, how's it going? Good. So, any questions?
This is about the lab.
Okay.
So, in the VI editor on the Pi, using I doesn't allow you to insert anything.
You should.
It's not working for us. Like we'd hit I and then it would just print I, and then hitting like up arrow would put an A, and down arrow put like an uppercase B.
Oh,
like
so the up arrows and down arrows may not work, and there should be some verbiage online that will tell you how to fix that.
We couldn't like delete or backspace either. Like it was just really weird.
Yeah, it's like real VI.
Okay.
So go to linuxengrcs.com/tilde-nick. I think this is on 224 Canvas.
You said look like Canvas?
Yes.
How-to guide?
So, here, let me put this up here.
What was it turning on?
So linuxengrcs.com/tilde-nick/ should be under shared /exrc. And there's a README in there, and the README says if you copy this own file to your own .exrc, it should restore the behavior you're used to as far as arrow keys, backspace, and insert mode. So you want to go to this file here, copy this, paste it into a file in your home directory on the Pi called .exrc, and watch out for line wraps. So make your window big and just copy all of that.
And then it'll work like we do. It does that.
And then it should work like you're used to.
Okay.
Right, so your home directory .exrc.
And will that just be if like will we need to download that program that lets you look at a file through Windows, or can we just use like the file explorer to find where that should go?
What do you mean?
You're saying to put it onto
So log on to the Raspberry Pi,
Yeah.
right? VI space .exrc, right? Say I, just go into insert mode. Come over here,
Oh, just copy paste.
copy paste, right?
I
Drag
know
all
you
that.
I tried copy pasting before, it doesn't do anything.
Usually middle key pastes.
Oh, it's not Control C or Control V.
No, so Control C here to copy, but usually on Linux middle button pastes.
Like the little mouse button.
Yeah.
Oh,
So like,
oh, that's weird. Okay.
so VI, and I'll just go into insert mode, and I'll hit the middle button, and it pastes all of that.
Okay, that's good to know. All right.
That's pretty standard Unix actually, so it's a good one to
That helps a
know.
lot.
Yeah.
Every time I want to copy or paste something, I've just been making a file and copying it, and then just renaming the file.
Yeah, so PuTTY has, if you're using PuTTY to connect, or you can go into one of the menu options and do a paste like that.
Oh, it really is?
But,
Okay. That's
but,
much easier one.
and PuTTY is selectable what the middle button's gonna do, and if it doesn't paste automatically, you can set it up to
Okay.
treat the middle button as paste. But if you use SSH to get into the Pi, middle button will paste.
Can you copy from the VI as well?
I mean, you can highlight stuff in the Pi, and then
Yeah.
paste it on your server or your own machine.
Oh, so, but you can, so Control C isn't what you use though, I assume?
No, so usually just highlighting with the mouse copies.
Oh, just on that?
Yeah.
Okay.
But check the settings in PuTTY, because I think it's selectable. And pay attention to the note that I posted in an announcement about setting the window size and adjusting things, because that'll look weird also. All right, other questions? So everybody got PA2 submitted? Okay, cool. All right, well, yes.
I had a question about page two.
Okay.
Did you expect us to give source code as well?
That's all I need is the source code.
Okay.
Did you not send me the source code?
I gave that.
Both is fine, yeah. But yeah, I can't grade the executable because I got to see the code. But I'm planning to compile the code myself. So. Say again? You had trouble with getting, sorry. Trouble with getting what? Did it compile okay? Or you can catch me at 12 right after, or 11:50 right after class if you want to show me. So deciding how many sticks to play with?
No, just like we're going to get several command line arguments and command line arguments.
Oh, okay. Yeah, show it to me. Let's see what you're doing, and we can talk about it.
I had one problem with it. I wasn't sure what it. I was trying to make like a function where you have like the total number of sticks, where it does like it, where when it would check the command line argument, it would show that it would show 12. But like if I put 12 in, it would show 12. But if I did it from like if they didn't do a command argument, it would put 49.
Okay.
I feel like I'll
Every
probably
time?
have to show you the code. Yeah, like every time
Really?
it's 49. Yeah.
Okay, that's interesting.
So I ended up just not having the function rather than putting it in separate spots. But
Okay.
I can show you the code.
Yeah, you can show it to me because it was probably
I
something
tried
good to
the,
figure out.
Rewatching your video about like addresses and stuff, and then when I did try stuff, then I would get random numbers. I could never actually get the number it was supposed to be.
Okay. Yeah, let's look at it later.
Okay.
Question?
Oh, it was more like answer to that.
Okay.
So like hex 49 is the digit 1. So when you type in 14, you're probably getting the decimal or the integer version of integer 1.
Okay.
That makes sense.
Kind of. I can talk to you about it later. There's a little more insights I can show it to you.
All right, let's play around with something here. So I have a piece of junk code here, right? It's a main program. It takes argc argv and it just sets an integer I equal to 0, and it doesn't do anything else particularly interesting. But I want to run this through GDB, and I want to take a look at argc and argv. You don't need to write down what we're about to go through here, right? I want you to think about the process, and the goal here is to use GDB to try to figure out a little better what exactly argc and argv are. Okay, GDB will let us look at variables, it will let us look at memory, and I just want to kind of take apart what's going on when we run a program with some command line arguments. And this is typical of the kinds of things you can do in GDB. Now, GDB is good for debugging code, but it's also good for exploring your system, for answering questions like, what exactly is argv? If it's a pointer to a character, what does that mean? What does that look like, right? And this is going to be stuff we do a lot in 222. Okay, we're going to be spending a lot of time in GDB. But let's start taking a look at this just kind of for kicks on a Friday. Everybody knows there's no class Monday, right? Okay. So I'll compile this up with a -G switch. I'll say GDB PTR. And I'll say start. And it tells me that I'm inside a program called main, a function named main. It tells me argc is equal to 1 and argv is equal to this crazy thing. Now, we didn't put any command line arguments on here, right? We just said PTR, the name of the program. So we expect argc to be 1, right? And that's just a regular variable. I can print it out, print argc, it shows me it's a 1. And argv is just a variable. I can print argv, and it's this big, long, crazy hexadecimal number. So argv is this. So 7 with 7 Fs, and then an E4, 9H. And that's supposed to be a car, star, star. Well, since it's a pointer to something, this is supposed to be an address in memory. Okay, we can examine memory using the X command. So we can say, let's examine this location in memory. And we find the following in there. So what does this thing contain? And it's 64 bits. So I'm going to look at the successive location also to see the full 64 bits. And this location in memory contains the following. 7 with 7 Fs, followed by E7FH. And the next location in memory is going to be E4A0. And I can just hit enter and it'll keep examining successive locations. And E4A0 contains a string of 64 zeros. So this is argv. It's an array containing this thing followed by this thing. Right? argv is equal to this number. That's the location in memory where the contents of this array is stored. So this number here is argv bracket 0. This number here is argv bracket 1.
Those are pointers, right?
Those are pointers. So when you see things with a 7F blah blah blah, it's usually a memory address. If you took 270, we talk about the stack, this little thing inside the PIC that gets return addresses on it. This is inside stack space. Okay, x86 processors, stack space usually starts at 7 with a bunch of Fs, and it grows up. So these are valid memory locations where temporary things have been stored. So let's take a look at this location, 7FFF, E7FH, right? So let's examine 0x7FFFFFF, E7F8. So this location here, right? argv points to a location that contains this address. Let's see what's at this address. And it's a 2F, 6H, 6F, 6D, and some other stuff. And if you've stared at enough of this stuff, you recognize that these are ASCII characters, printable ASCII characters. Anything in the 40, 50, 60, 70 range in hex is usually printable letters. Well, the 2F is an ASCII code for a slash. 68 is an H, 6F is an O, 6D is an M, 65 is an E, 2F is a slash. So the contents of memory starting at this location looks like /home/, and it goes on from there. Now we can also cheat. We can just say print argv bracket 0. And so now I'm asking GDB to print the contents of this location in memory, but it's going to know that this is ASCII, and it's going to show me exactly what those ASCII characters say, and they say /home/nic 224 PTR. That's the program name. That's argv bracket 0. And if I try to print argv bracket 1, it's null. That's this 0 right here. Now if I try to scanf argv bracket 1, it's going to try to go to memory location 0 and see what characters are stored there. And you cannot access memory location 0. So GDB is very polite about it. If I'm actually running this, it's going to say segfault. So let me put a breakpoint at main, and instead of just saying start, I'm going to say run, and I can name command line arguments here. And it will run my program as if I had said program name followed by command line arguments. So I can say hello 23 by, And so I hit my breakpoint at main, and it's telling me that I called this function main with argc equal to 4 and argv equal to this address. Okay, E478, which is different from what it was before. Well, argc is 4 because I ran this program with the program name, right, PTR, followed by 3 arguments. So I can print argv bracket 0, and that's the name of the program. I can print argv bracket 1, and it's the string hello. Right, but if I actually examine argv, right, so that pair forms the address of argv bracket 0. These next two are the address of argv bracket 1. So if I examine E7FE, that's argv bracket 1. And that's ASCII for HELLO followed by a null terminator. So with GDB doing things like this, and with enough patience and clean sheets of paper, right, you can make a memory map. You can figure out exactly what is stored where. And there's a lot of stuff sitting in memory that was created for us by the operating system. When we said let's run our program, the operating system places those arguments into memory and sets up argv to point to the address of the first argument. And the next location after that will have the address of the second argument, and so on. So this is actually fairly productive to play with sometimes, right? If you're trying to figure out how this stuff gets laid out in memory, how argv is a pointer to a pointer rather than a pointer to the first argument, right? Sometimes taking it apart like this can help. And it can drive you crazy, which isn't bad. Right, because you got to go through that to get to the other side, and then on the other side usually there's a more solid understanding. So that's just something I wanted to touch on. Let me show you a different example. So here's some more junk code. It's a main program, sets an integer y to 100, passes the address of y to a function, and then prints out the new value of y. And in this function, we take the argument as a pointer to an integer. We take the thing pointed to, and we change it to a 5. And we just return a 1. We don't do anything with that except store it in y. So if I run this, right, it'll tell me that after my function call, my new value of y is 5. So let's compile this with a G switch. And let's run this in GDB. And we'll say start. And we'll say next. So y is equal to 100. Now it's about to call function with the address of y. So let's take a look at this. Let's look at y. Y is equal to 100. Let's look at the address of y. And y is stored in memory at this crazy address. So 7FFF. Followed by E3A0. And this is where y is stored. And if I examine that location in memory, I see this number, 64 hex. What's 64 hex in decimal? 100. 6 times 16 is 96, plus 4 is 100. So that's the current value of y. Now I'm going to go into my function, so I'm going to say step instead of next. And it tells me I just entered a function named function. It was passed one argument called num, and the value of num is 7FFFE3A0, the address of y. So inside my function, num is not 100. It's a location in memory. But at that location in memory, I have the number 100. I have the value of y. And when I say star num equals 5, what that says in C is go to this address in memory and store a 5. So before I do that, if I examine that location in memory, it's got a 64. If I say go ahead and set star num equal to 5, and now I examine that same location, it's been changed to a 5. And that is the location that main uses to store y. So my value of y in main has now changed to 5. That's how we get things back from functions, right? When you use the ampersand, that's how scanf does it, that's how we can do it. So already main's value of y has become a 5. So I can, next out of this, get back to main, and now when I print y, of course, it's equal to 5. All right, one other thing I wanted to mention with GDB that came up in the last class. So I'm debugging my sort program, so let's go ahead and say next and next. I'm about to do a printf statement, okay? If you accidentally say step, right, step says step into the function, right? If we want to actually debug this function that's about to be called, we say step. But if you accidentally say step when you're about to do something like printf or fgets or scanf, you start getting weird stuff, right? We're in some function called io_puts that came from a program ioputs.c, and we're at line 33, but we don't have the source code for that because we didn't write it, right? So we're actually debugging the printf statement now. We're inside this function printf, which is doing ioputs, and ioputs was called with this enter a number as its argument. And if we keep stepping through this, you can see the line number is going up. We're in something called stringlen avx2. It's probably trying to figure out how long our string is. And now it's calling ioputs with this. And so this is just kind of like weird, right? But eventually, it may come out of it, or it may not. And so at this point, I think it's actually like printing out my string one character at a time, because I see the ch equals 110. That's an ASCII code. And then it'll come back and it'll do ch equal 116. That's another ASCII code, and so on. Okay, if you get into this state where you're debugging system level code and you don't want to do that, your favorite command is finish. And finish says, okay, just plow through until I get to a return statement, and then come back to the debugger. So finish will get me out of this io new file overflow call that I did, and it brings me back to file ops. And if I hit finish again, it'll take me out of there. Now I'm back at ioputs, and now I'm back into my program, right? The statement after that printf, where it's about to do my while loop with my fgets. So now if I want to do this, I'll remember to use next so I don't start debugging fgets. I'll type in my input, and I'm back to debugging my program. Or you can just Control-C, Control-D out of that and start over again. But if you've been in a debug session for 20 minutes, you don't want to lose all that progress, try the command finish. Okay, and that should scoot you forward to the next return. So debugging is kind of an essential part of programming, right? We don't write perfect programs usually the first try. Getting good at debugging is a really, really important skill, but it's also a really good way to sort of like solidify your understanding of things, because it lets you look at your code one instruction at a time. It lets you see what's going on, and if there is something that you're not quite understanding right, a lot of times going through GDB will reveal that. And the worse the bug, the harder it is to find, the more valuable the nugget you're going to get to at the end. Okay, almost always. Once in a while it's something really, really silly, like you started a comment and you forgot to end it, and so a whole bunch of your code is commented out. But after a while, right, you get good enough with GDB, you'll find things like that pretty quickly. You say if x equals 5 instead of if x equals 5, you'll see that pretty quickly, right? Because you'll fail the if statement, you'll check x, suddenly it's 5, right? But the ones that you just can't figure out, and you're just going line by line and scratching your head and can't find what the problem is, right? Those are the most valuable learning opportunities because they're specifically tailored to what your misunderstanding is, right? And each of us have certain things that we don't quite have exactly right. And when you've got a bug and you can't figure out what it is, that's the problem for you, right? That's the perfect exercise to help you figure this out. So don't throw away your code and start over or change things randomly and hope it works, right? Dig into those. Try to understand your bugs. That's more important than getting rid of them, right? Because they're actually really, really huge for learning. All right, so let's look at PA3. So PA3 is a high-low game. It's going to be a bash script that plays high-low. So let me show you what this looks like. I say high-low, hit enter. It says, welcome to high-low. Please think of a number between 1 and 100, and I'll try to guess it. So the user who is running this program is thinking of a number. The computer is trying to guess it. Okay? So who wants to think of a number? Without telling us what it is. All right, you got a number in mind? Between 1 and 100?
Yeah.
Okay, cool. So it tells you welcome to high-low, and the first thing it should do is say hit any key when you have a number in mind. Okay, don't just start making guesses. Give the person a chance to think of a number. So I'll hit a key, and it says, is your number 50? And you have to say if that guess is too high or too low or correct.
Higher.
So 50 is too high?
No, we go higher.
Okay, so 50 is too low, so you're going to respond by typing an L. Okay, so is 75 high or low?
High.
75 is high? Okay, how about 62? Low? 68? Too high or too low?
It's too high.
Too high, okay. 65?
Yeah.
That's the one? Okay, so you can say C, and it'll say, excellent, took 5 guesses. Additionally, you can say high-low, and you can put a number after it, and it will try to guess a number between 1 and whatever that number is. So we can play high-low from 1 to 1,000,000. Who wants to think of a number between 1 and 1,000,000? Okay, you got a number in mind? Okay. So is it 500,000? Is that high or low?
It's high.
That's high. 250,000.
High.
That's high. 125.
It's high.
Did you pick one? Okay. 62.5.
It's high.
31.2.
High.
15.
It's high. I think I picked the number a little bit small.
That's okay.
High. High. That's low.
All right.
High. 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 Low. Low. High. High. Low. That's it.
Correct. All right. So it took 20 guesses to figure out your number. So 1,000,000 possible numbers that you could have picked, right? And it only took 20 guesses. And you can guarantee to guess that number in, I think, 21 guesses max. Right? So that's the goal, is to write this program that will guess your number in this optimal way. And we'll talk about the algorithm for doing that in a minute. But let's look at the actual assignment. So this is on Canvas. So you're writing a bash script, okay? So we're back to bash, no C. Write a bash script that will play high-low against the user. So the user types the name of the script, which must be high-low, lowercase, 7 letters, hits enter. Program prints a welcome message. You can be as polite or as rude as you want. Tell the user you're going to play high-low. Ask them to think of a number between 1 and 100, and then hit any key when they're ready. Okay, let me tell you how you do this hit any key. If I say read data, I can type stuff in, but nothing happens until I hit the enter key. Okay, and then if I echo data, it's whatever was typed in. Okay, so read, we can put a switch on -N1. It says read one character. So if I say read -N1 data, I don't have to hit the enter key. I can hit any character, so I'm just going to hit the 6 button, and my read comes back. And now my variable data is equal to whatever that key was. And if you say read -2, then it will wait for you to hit 2 keys. So I can type A followed by B, and now data is equal to AB. So everything you do in this game, you're going to want to use a read -N1. Okay, so that you don't have to type H, enter, L, enter, L, enter, L, enter. You just hit H or L or C, and it'll respond after that one keystroke. So that's the first trick, right? And in the very beginning, ask them to think of a number and hit any key when they're ready. So the user thinks of a number, hits a key, program makes a guess, and the user says whether that guess is correct or too high or too low. And if it's too high or too low, the program makes another guess.
So when this is right, so before they should enter a key, and then whatever key they press next, then it should go to the next line.
So you say high-low. It says, welcome, think of a number, hit any key when you've thought of a number. Okay, so the user thinks of a number, I'm going to think of 50, and then hits a key. Okay, so it makes a guess, and now you say either H, L, or C. And if that's correct, I just hit a C, and it's like, okay, I got it in one guess. All right, so if the program's guess was too high, the user hits H. If it's too low, the user hits L. Okay, and don't get those backwards, because it makes sense either way, but I want it to be like this. And you just keep guessing until it guesses what your number is. And if you run high-low with an argument, it guesses a number, it lets you guess a number between 1 and that argument. Okay, so important detail here. If the program is run with an argument, you can safely assume that is a valid positive integer. Don't error check it. Okay? If I say high-low space something, you can assume that something is a valid positive integer. And just go ahead and use that as the upper bounds. Okay, I'm not going to say high-low space ha-ha. I'm not going to say high-low space A, B, C, D, E, F, G, right? If I say high-low with anything after it, it's going to be a number, positive integer, and you play between 1 and that number. All right, so details. It's got to be a bash script. Got to comment your code, comment block in the beginning with your name, class, date, description of the program in your own words, and comments in the code itself. Okay, we did this in PA1, so anything you're doing that's not completely obvious why you're doing it, put a comment in there, right? At the end of the line, you can put a number sign and write some stuff, or you can write a line before or after with a number sign to say, you know, what are these next few lines doing, that kind of thing. So pay attention to commenting. Don't require the user to hit enter. Use that read-N1 to pick up just a single keystroke. We'll talk about the algorithm shortly. We'll talk about how to detect cheating. But for example, so I've got a number in mind, and 50 is too high, and that's too low, and that's too high, and that's too low, and that's too high, and that's too low. It's really got to be 33, right? Because 34 was too high, 32 is too low. So if I don't tell it that 33 is correct, if I say, oh, that's actually too small, right, it's got to detect that and say something's wrong, you're a dirty cheater. Or you can say, maybe you forgot your number. Okay, so you want cheat detection. We'll talk about that also. Name the script high-low. Next detail, you're going to upload this to Canvas as a plain file. Don't tar it, don't gzip it. Just upload high-low. Okay, and it'll accept any upload types, but make it just a plain text file. All right, and then things to keep in mind. Make sure that it's the user who's picking the number in the program it's trying to guess. Okay, don't have the user try to guess the computer's number. That's a backwards version of this. Makes sense, but it's different. H means the guess was too high. It doesn't mean you have to make a higher guess. Okay, H means the guess was high, L means the guess was low. Make sure you give them a chance to think of a number before they hit a key and then start playing the game. If they type in anything other than H, L, or C, just remind them what they're supposed to pick, right? And don't kick them out or anything. Just say it's got to be H, L, or C, and eventually they'll get it right. And good program to have other people try to break, right? I'll be trying lots of different versions of games on this with different ranges. I'll try to cheat, things like that. So, feel free to don't share the source code, but someone can come over and run your program and see if it works for them. And that's good. All right, so questions about the goal or the assignment submission, what you're supposed to do. We're going to talk about the algorithm next, but basic goal is clear. Okay, so let's talk about how we play high-low. So the basic idea, let's just go 1 to 100. Initially, you're told, okay, you've got to guess the correct number. It's somewhere between 1 and 100. We don't know where it is in that range. It's somewhere in between there. So we're going to make a guess right in the middle. Now, the middle between 1 and 100 is actually 50.5, but you can round up, you can round down, it doesn't matter. So we're going to guess 50. And one of two things is going to happen. Well, one of three things. 50 might be correct. We might just luck onto it, in which case game's over. Tell the person how many guesses it took. But suppose 50 is too low. Well, if 50 is too small a number, so is 49, so is 48, so is 1. Everything above here is too small. So we don't have to guess any of these numbers again. And we have a new game where we're trying to guess a number between 51 and 100. Right? And we tried 50 and they said that's too low, so we know 50 is not correct. So this whole range starting at 50 and going lower is no longer anything we have to consider. So we can start just looking at a game from 51 to 100. Okay, so where's our next guess? Somewhere in the middle of that. Let's say it's 75. And let's say that's too high. Well, if 75 is too high, so is 76, so is 80, so is 100. We can get rid of this whole range. And now we've got another game which goes from 51 to 74. And it's important we don't go 51 to 75. We want to take advantage of the fact that 75 is too high, so it can't be 75. So we'll come to 74. So what's happening here is each time we make a guess, we're basically cutting the problem in half. Okay? This is something we'll call divide and conquer in 222. It's a standard approach to algorithms where you basically reduce the problem size at each step. And in this case, the reduction is pretty significant. The problem gets cut in half. So if you're guessing from 1 to 100, your first guess, you have 100 possibilities. After one guess, you've got 50, and then 25, 12, 6, 3, 1. And eventually you're going to get down to where there's only one possible guess. And then that's your final guess. And if that's not correct, then you know the person is cheating. So the number of times you can divide something before you get down to 1 is basically log base 2 of that number. We'll encounter this a lot in CSE 222 and 223, because when we talk about algorithms and the efficiency of algorithms, a lot of them come out to have this log n behavior, and those are generally the more efficient algorithms. So this is a very efficient way to guess numbers. If you have 100 numbers, log base 2 of 100 is around 7. It's a little less than 7. but if you round up, 7 guesses will get you an answer. If you go to 1,000, log base 2 is a little less than 10, so 10 guesses. If you go to 1,000,000, 20 guesses. If you go to 1,000,000,000, 30. If you go to 1,000,000,000,000, it's only 40 guesses, right? And if you just randomly guessed numbers from 1 to 1,000,000,000, it could take you 1,000,000,000,000 guesses. If you use this divide and conquer, 40 guesses guaranteed, you can figure out what the number is. Okay, and we're going to see this when we talk about sorts and searches and all kinds of other things that we do in computer science that we want to make efficient. And we'll see how to use this, for example, to search for a number out of a list of 1,000,000,000,000 things, and we can find that number in 40 tries. And we're going to do that by basically playing high-low with our data. Okay, so we'll actually come back to this in 222 when we talk about binary trees. All right, so how do we do this? What's our algorithm look like? We need to know a few things. We always need to know what the lowest possible number is, and we need to know what the highest possible number is. And I'll just pick on 100, but if you have an argument, set high equal to whatever that argument is. And then we want to make a guess, and we're going to guess right in the middle, because our guess is going to eliminate everything either before or after our guess. And so if we put it in the middle, we're going to eliminate exactly half. So what's the midpoint of low and high? It's just the average.
Is there a math function in bash to round?
No, but it will round for you automatically.
Okay, so you don't have to worry about dividing and then rounding it to the operating.
Right, because if, 100, because if we echo high plus low over 2, it'll just give us 50.
Okay, that's good.
So I think it rounds down. Yeah, don't do something fancy where you get real numbers, because then you're going to guess 50.5 or 25.25, and that's
what was
gonna,
worrying me. Like,
yeah,
things
that
get
would be
complicated really fast.
a non-feature.
Okay.
So yeah, so this will give you an integer.
Okay.
All right, so find the midpoint and then say, is your number, midpoint? If it is, you're done, you got lucky. You can have the cow come out and declare its superiority or whatever. But if it's not correct, right, suppose you guess the mid and they say that is too low. Okay, so mid is too small. Anything smaller than mid is also too small. So everything from low to mid is out of contention. So if mid is too low, then we can change the lowest possible number, and it's actually going to be mid plus 1, and that plus 1 is critical. Right? Technically, we could set low to be mid. I mean, that's fine. We haven't done anything wrong. But we can also eliminate mid because we guessed mid and it wasn't correct. So really, the smallest number it could be is mid plus 1. So set low equal to mid plus 1. Otherwise, mid is too high. And so mid is too big, mid plus 1 is too big, mid plus 2 is big, high is too big, right? It's got to be something smaller than mid, so we can change our high range to be mid minus 1. Because again, we can eliminate mid. And then we basically just go back up here. Find the midpoint in our new smaller range, ask them if that's high, low, or correct. And if it's too low, change low. If it's too high, change high.
So maybe it's just me not fully understanding the algorithm, but this almost seems like it's easier with the stick to code.
Yeah.
Okay. How come it's the after stick then if it's easier?
Oh, I don't know.
Okay.
The algorithm can be a little confusing to people, and the algorithm for stick was really just one thing, which was this modulo thing.
So the algorithm's more complicated, but the code will be simpler.
Yeah.
Okay.
Well, but I mean, it's possibly simpler because you've already done stick.
True.
But yeah, there's not a whole lot in here that's particularly complex, right? It's just sort of getting the pieces together in the right way. But it's simpler because You don't have to exit out after they make mistakes, and you can assume the argument is a positive integer and so on and so forth. All right, so as we do this, as we change low and high, we always want to do a check and see if high is smaller than low. And if it is, then there's cheating going on. So high should always be bigger than or equal to low. And here's what can happen. Let's say low equals 49, and let's say high equals 51, and we pick the midpoint, and that's 50. And let's say the person's actually thinking of 49. Okay, so this is actually the correct answer. But we've sandwiched it down to somewhere between 49 and 59. Computer says, is your number 50? And we say that's too high. Well, if it's too high, we're going to change high to be the midpoint minus 1. So high is going to change to 49. The game is not over. Okay? We still have to find the midpoint between low and high, and that's going to be 49. And we're going to say, is your number 49? And if the player's honest, they'll say yes. Okay? But if they say no, if they say 49 is too low, right, then what are we going to do? We're going to change low to mid plus 1, which is 50. And now we're going to say, hey, high is smaller than low. There's a problem. Right? Or if low is 49 and we say that's too high, they're going to change high to be 48. And again, high is going to be smaller than low, and we'll say it's a problem. So this is your cheat detection. But it only works if you're doing this plus 1 and minus 1 on there. If you do it like this, it will work. Okay, it will work first try, and it will be glorious. If it doesn't work like this, come back to here and see if you're doing this, right? You can start adding on code and doing special cases and putting in special checks and all kinds of things and maybe get it to work, but it's really this straightforward, okay? As long as you're picking the midpoint, adding 1 or subtracting to adjust your low or high, and then doing this each time the low or high change to see if there's a cheat. All right, so that's PA3. I will get your PA2s graded sometime in the next few days. And we will continue with this on Tuesday.